Hello and welcome. I'd like to start by asking the audience two questions. One would be, how many of you are front-end or JavaScript developers and use JavaScript in their regular work? All right, like half an audience. And how many of you started working or tried decoupled Drupal and new technologies like React, Vue.js, things like that? Also half an audience, so that's great. All right, I'm asking that because in this presentation, we will mostly talk about how to optimize and why do we need to optimize JavaScript in our new applications, mostly using tools like Webpack and frameworks like React or so. Let's start by talking about a little history in the recent 20, 30 years. So we all need to thank the ARPANET project that started the internet revolution in 1994. And that's also why we are all here. We are all connected by the internet. And there are two or three more important things that happened too. So maybe not all of you know, but Drupal was actually started before Facebook. So yay for Drupal. And after that, yeah, Facebook started, but in the late 2009, 2008, mobile phones started a big revolution. We got bigger screens, we got faster CPU processors, we got GPU renderings, all this kind of crazy stuff. And what is also really interesting is that by now, already 50% of the whole population is connected to the internet. So let's dive a bit deeper into those numbers. Let's take a look at the share of web traffic by device. So if we take a look at this survey done by We Are Social, which is a UK-based agency, we can see that in the year 2018, we surpassed the 50% ratio between mobile phones and desktops by users surfing the web. So we see that in the last year or so, we got a drop of 3% for desktop users and 13% of tablets. So not many people actually use their tablets to browse the internet nowadays, and there's only 1% or so of users that use, for example, extra devices like PlayStation or so to surf the web. So I think we should really focus in the direction of mobile phones to optimize our websites in that direction. But not only that, we see this issue nowadays. And if you try to tap a link or if you try to navigate the site, this gets really frustrating, right? I think everybody of us noticed that. For example, not many of you may live in the city center where we have fiber optics or strong Wi-Fi connections, right? So let's take a look at more issues or more whys this issue happened. So, as I said, the 4G coverage in the world is not so spread. We have, for example, different 4G speeds for different countries. For example, we should also think for a broader scope when we develop our websites, not only for the US, the Europe, the more developed countries, but also people surfing the web from, I don't know, Asia or India or so. So other than that, we also have the issue of older smartphones. So in that case, older smartphones have older CPUs, which may consume our resources much more slower. That's why our websites can get unresponsive for a very long time. So we should also target older mobile phones. And last but not least, when users access your site, you're probably sending down a lot of files, many in which are scripts actually. And by the browser perspective, it may look something like that. And you can't really stop that. Like the page just loads and loads. Unless you close your browser or navigate somewhere else, the page will keep loading and your data will not be shown. subsequently. So let's start by talking about JavaScript. Since we all love it and it brings so many new cool features, it makes the world go round and all these things, but at the end of the day, it's always the most expensive part of your website. So 10 years ago, the network was the main bottleneck, but nowadays JavaScript is, it's sad but true. So if you just look at the numbers again, the amount of JavaScript on pages is growing rapidly. So for around 5 times in the previous 7 years. So in order to keep pages rendering and filling fast, we need to focus on JavaScript CPU time, and we need to think about how to reduce the blockers from the JavaScript that blocks the main thread or the rendering of our website. So JavaScript has a huge cost. Modern JavaScript applications today will often send the following in their JavaScript bundles. So first and foremost, we use UI libraries or frameworks like React, Vue.js, which are amongst the more popular nowadays. Second of all, we need some state management tool, for example, Redux. Then we also use some polyfills, for example, the Internet Explorer, things like that, or maybe also some polyfills for JavaScript itself. For example, a lot of users use polyfills for promises, which are already implemented in ES6, so we don't need to add extra functionality on top of that. Then we also sometimes really load full libraries, for example, Lodash or things like that, so that can all bloat our website. And last but not least, we have the UI components like buttons, headers, all this stuff all bundled together. And this code really adds up. So the more the bigger the file is, the bundle, the JavaScript bundle, the longer it will take to load a page. So here are more numbers, so it looks like I really like statistics. These are the numbers for the Drupal, the average Drupal websites in the last 3 years. So if we take a closer look, we see that the numbers are dropping drastically, so that's really great. We are reducing the size of JavaScript bytes that we are sending to our users. We are reducing the JavaScript requests. And also the JavaScript put-up time is lower. So that's really great. We are making great progress. But if we take a closer look and if we do some calculations, 19 times 0.5 is around 10 seconds. But then we also need to understand how the JavaScript and the browser gets compiled and everything that is behind. And all this can add up to around 15 seconds of loading time, and that's really a lot. So if we need to understand how JavaScript and web browsers work. So because JavaScript needs to be downloaded, parsed, compiled, and executed, this can take much longer than just decompressing normal image files. So here we can see that 170 kilobytes of JavaScript bytes are not the same as 170 kilobytes of JPEG files. In this case, it takes around 3.5 seconds to load our JavaScript files, but just 0.1 second for the same size of an image. And that's really a huge difference. Here we can see a loading timeline of our website. This is an example, and yeah, we can see that loading is a real journey. So we have 4 main parts of the timeline, which are the first paint, the first contentful paint, the first meaningful paint, and the time to interactive. What I think here is that we need to shift or increase our focus about caring about user-centric happiness metrics. So, for example, we need to display meaningful content to the users as fast as possible, but also as effective as possible. So here in this example, we are first loading the images, the users, and then the text, subtitle, things like that. So our goal, again, is to cut loading time, display useful data, and make it usable ASAP. So here, the users may be asking, is it loading? Is it useful? Is it usable? Nobody wants to be stuck in the middle, in the useful position where the users can try to scroll or tap somewhere, or try to, for example, book a reservation or buy something, and then he cannot do that because not all the content is loaded. If you need more whys, here are a couple of more perspective from the marketing side. So for example, if we serve data quicker to our users, it's more likely that they will stay on our page, browse more pages, click around, order new things, so it's more profitable for us in the long term. Nowadays, also, mobile page speed is an SEO ranking signal, so we should also think about that. So if you want our web page to be at the top when the user is looking for a web page, there's also a really good optimization tip. There are also a couple of questionnaires or statistics that show that attention spans are decreasing rapidly from users browsing our mobile websites. So, and I've read just before that our attention span is actually less than an attention span of a goldfish, which is really crazy. So a goldfish takes like 9 seconds of attention, and then it just goes away. But we usually have around 5 to 7 seconds of attention time. So that's crazy. And yeah, our users are less tolerant and when dissatisfied. So yeah, we need to really improve the speeds there. And last but not least, for greater success, we need to focus on mobile speed also because of advertising costs. So that's logical. So yeah, my name is SAŠA NIKOLIĆ, and we already saw the whys, and in the future slides we will take a look at how we can test our websites, how we can actually improve. We will see some code, and at the end, as an extra tip, we will see how we can improve our APIs and how we can basically also do micro changes in our JavaScript code that will affect our website performance. So the workflow for testing our websites are really simple. So we first need to measure our websites with different tools. Then after we get the results, we can focus on how to improve and optimize our websites. And with time, it's important that we need to measure and monitor. This is really important. Because as we add different code, we have different developers who think differently, our code just explodes. And it's just with complexity arises also the size bundle, the JavaScript bundle, but also it's really hard to debug the code. So there are different tools to measure. As we can see here, there are so many of them made by Google because Google is one of the main companies that try to push us to improve our web browsing performance and experience on mobile phones. So we can see here we have the Chrome developer tools. I guess everybody here is using that. That's quite standard. Then we have the web page test, the page speed insights, and Google Lighthouse, which is one of my favorites. We also have Google TestMate Site and some extra tools like Calibre, Speed Curve, Benchmark.js. There's also, interesting enough, a Swiss solution called JSBan. Maybe some of you are using that, not sure. And there are some extra tip. So we can, if you're a Linux user, you can use ls-l to see, for example, which files are the biggest and which can be split or which can be improved. So that's a nice shortcut there. So you don't need to compile the whole code and check that. It's always better to isolate the changes and run an audit after each change. That's really easy to do, but it can be time consuming, I know. So if we do multiple changes, it would be really hard to understand which one really affects our web page positively or negatively. All right, let's take a look at Google Chrome developer tools. I really like the feature of Google developer tools that you can target different mobile phones. So as said before, we don't need to test, or we must not test our websites just by the 4G and iPhones, current iPhones, or things like that. But we should also target older websites. And Google Chrome developer tools is one of the rare tools that can do that. So actually, if you click up there in that red box, you can actually toggle different settings, different mobile phones, and different speeds. So you get a clear insight of what is happening in different environments. Then let's jump to Lighthouse and let's try to make an audit of a Drupal built website. First and foremost, I think it's a really useful tool, but also really easy to understand, and you just need to click around. For example, we can target mobile phones or desktops. We can also do audits for accessibility, SEO. We can get tips on best practices. But in this case, we will just take a look at the performance because we are interested in that. At the bottom, we can also toggle the CPU throttling. We can test it with 4G or 3G, but it's not so specific about which device to test. All right, let's try to run an audit. And this is the response that we get. So we get this data back. And we can see that time to interactive is like 10 seconds and a half, which can be quite improved, I guess. The whole score is like 54, which is in the middle. But what is also interesting here is that we get the timeline at the bottom, and we can see how our web page actually loads on mobile real devices. Yes, and what is also really useful, we get this insight of opportunities, how we can actually improve our website. In this case, we need to eliminate render blocking resources. So for example, we can lazy load some JavaScript code. It's really important that we put all our JavaScript code from the header to the footer, so it loads last, and we don't load the JavaScript before some text or something like that. So let's jump straight into optimizing, how we can optimize our JavaScript. There are two main branches what we can optimize. We can optimize the first page load, or we can reduce the second and every consecutive page load. So for the first page load, it's really important that we have a smaller bundle size. And for the second option, we need to understand how caching works, and we need to optimize that. So how we can reduce the size of our JavaScript? Basically, I guess everybody is doing that already on their servers. We're using gzip or something similar to compress our text-based resources. Again, there are many tools that you can experiment with, like Brotli, Zombflip, Packer, YUI compressor. I suggest you can try all of them, and there's a tool, Compressor-Rater, that you can use and understand how this works and what benefits can you get from that, and which tool is the best actually. On the other hand, it might be silly to see that, but you can actually pre-compress files locally, send that to the browser, send that to the server, and then let the server serve the pre-compressed files. So because even though JZip and other algorithms are pretty efficient, they still waste a lot of CPU cycles on the server. So the server needs to compress every time your user browses your website, and then send that back and forth for every user. So if we do that manually, we can actually save some CPU time on the server itself. And yeah, with this we can gain a lot of improvement on the first meaningful paint. So here's a table that shows what the differences between the gains of different tools. So here we can see that Brotli is actually one of the best tools to use. It's again made by Google, and with it we can get a drastically improve bundle size by 75%. So yes, JavaScript is often compressed when sent over the network, right? We minify and we do all this crazy stuff just to have our bundle size smaller. But actually what the browser does is it decompresses it, and then it needs to parse, compile, and execute our files. So at the end, this doesn't really matter much, right? So from 300 kilobytes of compressed data, the browser still gets 900 kilobytes or 1 megabyte or even more in nowadays websites, and that's quite a lot. So basically what I'm trying to say is that the compressing is irrelevant in regards to our resource and compilation time. I'm sure and I'm hoping that everybody of you is doing that too. Minification is really important. So before we deploy our code to the server, we really want to minify our code. So by minifying, we are stripping the comments and white spaces from our bundles, from our JS code. And to do that, there are, again, many solutions, but the best one seems to be Uglify.js for minifying the old ES5 code. But there's also Babel Minify and Uglify ES if you are using the new version of it, so ES6. Of course, there are many tools that we can use to optimize the size. This is one of the rare Facebook tools that we can use. It's called Prepack. And what it does, it actually makes JS code run faster. It's still in alpha or beta versions, so you can experiment with that. If that helps, that's fine. But let's take a look at an example what it actually does. So here we get rid of the intermediate allocation and computations, so our end code results in a single line. So if we can see this difference in code, it's quite drastic. In 4 lines and computations, we just get a 1 line compiled, which is quite cool. There's another Google tool that you can use. It's called Closure Compiler, and it's a tool for making JavaScript download and run faster. So instead of compiling from a source language to machine code, it compiles from JavaScript to better JavaScript. That's what they claim. So in theory, it parses your JavaScript, analyzes it, removes that code, and rewrites and minimizes what's left. So it can be quite a good tool to use. So it also checks syntax, variable references, and types, and warns about common JavaScript pitfalls. So it's like an ESLint tool too. All right, let's move to some more interesting stuff, what we can use in everyday life and what is really easy to implement. Code splitting is one of the techniques to improve performance by partitioning our application JavaScript into smaller chunks. So we can do different things with these chunks. We can do vendor splitting, entry point splitting, and dynamic splitting. Let's take a look at these 3 options in more details. So vendor splitting, we can think about that as having two buckets. So one bucket is called, let's call it bundle.js, and let's move all our node modules in there. So our node modules will be mostly static, right? We will not, we will update them once in a while, but the users should not care much about that. It will be static and cached and will not change every day. But what will change is our custom code in our main.js. So it's important to split those two and serve them separately, because we can do better optimization on the bundle.js and have it cached or so. Entry point splitting is best for non-single page applications where we have different routes. So it splits code across multiple entry points, and we serve only the chunks to specific routes that need them. So we can think that about that like having preprocessed functions in Drupal, where in a, I don't know, for example, we want to load some JavaScript just for some specific content types or for some forms or things like that. So we don't load the JavaScript and push everything to our to our users that actually don't need them. So we can do a lot in that direction. There is one thing that we need to look out for in this case. So if your entry points share some vendor libraries or modules, it can cause duplication of the code. And we can address this in the future slides. So here's an example of how to configure Webpack to manage entry point splitting. What we need to do here is just have an entry array with routes and what files to load on each route. So here we have two routes, index and another route, and we just add another route with our custom JS code that we want to load on that route. It's quite easy. So with the optimization split chunks configuration option in place, we should now see the duplicate dependency removed from our index bundle.js and another bundle.js. So if we just add these 5 lines of code, we can basically fix the double loading of extra or shared libraries. There is also dynamic code splitting. So you're asking when this makes sense. It's the third option, and when you're developing a single-page applications with many pieces of functionality that all users might not really use, right? So we can lazy load this functionality. So with that, we can reduce our JavaScript parse and compilation time, as well as bytes sent over the web. Tree shaking is also another important thing that we can do. So it's a form of dead code elimination tool or solution, as Rollup calls it. And what it actually does, it removes unused dependency. And this technique works because it doesn't address a common problem of JavaScript heavy applications. So, which is the inclusion of code that is never really used. So to solve this problem, we rely on tree shaking, right? And in tree shaking, here's an example of what it actually does or means. So we have this import of array utilities, which we don't want to use the whole package, but we just want to use single tools from there. So we just import the ones that we need. And by that, we eliminate all the extra functionality that is not needed by the site. And tree shaking is really powerful when we can use it in a combination with a bundler like Webpack and minification together, because by that we can, during the process of minification, the function fly will be stripped out from our code. So we will just import or use the drive function. So yeah, the drive function here is deprecated, and by using this solution, we can reduce our size up to 30%. I hope also ESLint, all of you are using that, because this is just extra add-on for your I don't know, PHP Storm or whatever tool you're using to code. And here is actually a package that is really helpful to me. So with this, it actually prohibits you to use some bad tools or some bad add-ons, plugins, whatever you want to call them, that are well known to the community. So if we just add this rule to our ESLint, we can improve our performance, because it warns us that Lodash is not a good solution to use. For example, we just want to load some particular things from Lodash. So reducing the size can also be done with Next.js. So I'm thinking that, and I'm suggesting that we should always look at new solutions out there. Next.js is a really common thing nowadays. So we really need to evaluate things like that. I've read some blog posts in the previous days, and they claim that they got a big boost of performance just by making a few tweaks with Next.js. It was painless, so the switch was really invisible to the users. They just needed to make a couple of things like deprecate the React router, because there's already a built-in solution in Next.js. It already has a pre-built code splitting solution, so we don't need to care about that. And yeah, they got a really big performance boost by 75%. All right, let's take a look at caching. So caching is used to optimize the subsequent loads of our website, and we suggest that we use the most recent tools like HTTP caching to ensure browsers cache responses effectively. In this case, we need to determine optimal lifetimes for our scripts. So we defined a max age for how long the script will live on our user's website. And we need to supply validation tokens, the so-called E tags, to avoid transferring unchanged bytes. Then another important topic is service worker. So with service workers, we can really cache our websites by intercepting network requests and programmatically manage a cache of responses. So this is a replacement for app cache. I'm not sure if anyone of you use that. And it's really easy to implement, actually. We just need to register it to the browser and then install it whenever that is needed. So with service workers, we get the opportunity to have features from native mobile applications, like periodic background sync, push notifications, but we can also make our web page work in offline mode, which could not be done before. So that's a really great progress, and I think there will be a lot of more done in that direction.
Sorry,
yes.
Offline mode is very old.
Is it?
Yeah.
For mobile websites?
Yeah, for any website that works since a very long time. There's a good blog post about the website for the Frontend United website.
Mm-hmm.
They have introduced offline functionality there. They have also shown that it works since a very long time.
Without web...
without the
service workers, yeah.
The new stuff.
Okay, interesting. Cool, thanks for the tip. And yeah, the third solution that we can talk about is the long-term caching. So I already did something similar to that to the Zurich.com website that won the award yesterday. So what we did there was actually what you can do in also your other web pages is to add some suffix to the websites, to the files actually, So it's called something like file name hashing. So you hash your file and change the hash whenever that file is changed. So you can actually cache the files more intuitively. And this can also be done in Webpack, of course. All right, let's look at some code-wise optimizations that we can do. So we really need to think when our code runs and for how long it runs. We need to reduce the complexity of our code. And in many cases, you can, for example, move pure computational work to web workers. For example, if it doesn't require DOM access or things like that. And we really need to optimize things like sorting or data manipulation or traversals, like, I don't know, searching, things like that. These are really heavy performance issues, and we really need to shift our thinking into that direction. What we can also do is lazy on-demand loading based on breakpoints. This is a really interesting blog post that I read a couple of days ago. So basically, when the user scrolls, we just load what it needs to be visible in the current viewport. And when for example, we want to load JavaScript just when the user comes to the footer, we don't do that on page load, but when the user scrolls down to the bottom of the page. So that's really interesting technique. And you use a combination of JavaScript, of course, with, I don't know, CSS styling or things like that. Then we can also do preloading, prefetching, and pre-browsing. These three things are also really important. But yeah, pre-browsing is a bit of a complex thing, so we will not talk about that. We can do a lot of micro-optimizations to our code. We can, for example, when we have some animations or things like that that can be done in CSS, why would we use JavaScript? This is a really resource-heavy thing to do, so we can just use CSS, right? Then we can use the new technologies like HTTP2. We can use native functions like getElementById, although IDs are not recommended to be used anyway. But yeah, use native JavaScript functions. You can also improve your event handlers. So you need to think about how can I write the code differently and not append click handlers everywhere, because this can reduce the performance quite drastically. So, and if you need to use them, you can use throttle and debounce. For example, when you're scrolling, it's really recommended to use debounce functions. The click function is also really, it's better to use than doing more complex things like mouse up and mouse down, things like that. But these are really micro optimizations that when coding, we can think about those. You can also reduce global variables, because then they all get bubbled up to the top of the element, and we can reduce that by having local scopes. We can use new things like let and const and things like that, but we can also define them in objects or closures, which will get us the local scope of our variables. Then, of course, I guess most of you are already using 3 equal signs instead of 2 equal signs. This can be quite good to use, and like also for long-term debugging. It's also a really good practice to declare variables outside of for loops. So you don't need to, you don't have the issue of overwriting things all over again. And of course, these things can be improved by using JSLint. This will warn you if you're doing something wrong or if you're doing some crazy stuff that should not be done. We should also not use eval and with functions because they are evil. So yeah, we need to think about efficiency. That's really important. But not So efficiency, I mean, if you're writing some complex things like sorting or things like that, we can simply Google that, or we can see how our code scales if we have if more data adds up. So I'm not sure how many of you were learning that in school, but this was a really important topic that we should think about and learn too. I've read a really interesting blog post by Dan Abramov, and he basically explains not the big O notation, the so-called, but the bug O notation. So this actually tells you how much an API slows you down as your code base grows. And in this case, we don't want to talk here about algorithms or performance itself, but the debugging is really important. So if we are designing an API, we want to have it really clear, and we want to have our developers understand our code really easily. And if we think about that in that direction, this code is really unusable, and it's really complex. I will just let it absorb. It can be really easily improved by having some switch functions, things like that, defining some global variables, but yeah, you can read this blog post. It's really interesting, and the problem is that if you look at this code, it's really hard to find a bug, and it's really hard to debug, even though the performance can be also improved. It's not the best. All right, so when we talk about the code growth and when our projects are finished, we need to monitor our web pages. It's really important also to monitor our changes when during coding. So for example, if you want to deploy a feature, it's really important to think about it like, does it add value? Does it decrease our performance drastically? And yeah, this is a really interesting quote. So all software ages like milk, not like wine. So that means it ages really fast, right? So yeah, we can monitor our websites constantly by using different tools like Source Map Explorer, Webpack Bundle Analyzer, and see how that changes. We also have, it's really important to audit third-party libraries. So for example, if you're using Lodash or things like that, there might be some libraries that work much faster or better than that. And we need to ask ourselves, do they provide any value to us? Or can this be done in native JavaScript? Or is it better if we write our custom solution that would work better for us? What is also really good to do is to lazy load embeds. For example, if you have some JavaScript iframes or things like that, we can lazy load it at a later time, so we don't need to display that at the beginning. I also noted before the polyfills. So for example, for JS promises, things like that, we don't really need to use it anymore, so we can drop some of them and reduce the code complexity. And of course, write tests. Every feature that you do might break some other features, so tests are really important. There are many tools to do that, like Behat test, or here's an interesting thing that Dries posted a couple of months ago. So basically for his blog, he was still using jQuery. So we all know jQuery is an old library, and you cannot, the code is quite big. So if you're just using jQuery to like write some functions or to have some, customizations, you can rewrite it in native JavaScript. And by doing that, he decreased the size of his JavaScript quite drastically. So it went from 45 kilobytes to just 700 bytes. So that's quite a All right, so performance budgets are critical because they keep everybody on the same page. This is the idea, and I would like to adopt that thinking in every company. So, performance budgets. We really need to think that the performance budgets, we really need to set performance budgets for each feature that we do, but also for long-term stability. We need to have our web pages load in less than 5 seconds per load, for example. We can set our goal to load web pages in 2 seconds on every subsequent load. And we also need to think about the global scope. And for example, we can say for European users, this should be, I don't know, we can set our JavaScript bundles a bit bigger and have some extra functionality, things like that. All right, thank you very much. Do you have any questions? Questions, everyone? Or too hungry for lunch? Do you have any tools that you're using or any experiences that you need to share, you want to share?
I've seen that you have declared some of your code with the old var
Yes.
attribute and then with the let. Isn't let not so valuable for you in terms of performance and behaving of code?
I like using let lately. It's much better than var. Var is the old syntax. I still need to use it in, I don't know, Drupal projects where we don't do decoupled or things like that because we cannot use the latest ES6 syntax.
Actually, you can very easily
Yes,
with Bubble.
Yeah, with Bubble, but we didn't implement that. For example, if you have some custom code in modules, you want to compile the code from the team to also compile the code from modules, and we need some kind of solution to like connect these two things together.
Yeah, you could work with Drupal libraries where you just compile JavaScript from a certain module, or you can even compile the entire JavaScript. For our cases, it works pretty well, so I really recommend Bubble. It's very easily set up, and the documentation is just amazing.
Yeah, I think we mostly use gulp and gulp functions to compile things. So yeah, we can include that.
We have thrown away gulp, and we are only using Webpack that has made our tool set a lot of more compact.
Mm-hmm. Yeah, I think we were using Webpack for our decoupled projects, but not for normal Drupal sites. Here are some resources that might be useful for you. All right, if no more questions, let's go for lunch. Thank you.